Welcome! In this video, we will be talking about trigonometric identities and how to derive them. There are many different identities, and it is very difficult to remember them all. Let us talk briefly about the trigonometric ratios first. Here we have a simple right triangle with an angle theta. The sides are defined as hypotenuse, the longest side opposite the 90 degrees angle. Opposite, the side across from the angle theta. Adjacent, the side next to the angle theta. That is not the hypotenuse. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent, meaning that it is also sine theta over cosine theta. We also have reciprocal trigonometric functions, which are cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent, so it is cosine over sine. We shall now go over the Pythagorean identity. Let us have a standard semicircle with radius 1 on the xy plane. We can draw a segment from the origin to the circle as shown, creating an angle theta with the x-axis. This makes a right triangle. Because the circle has radius 1, we can obtain these trigonometric values. Then, from the formula of the circle shown here, we can substitute these values x and y. This yields sine squared theta plus cosine squared theta equals 1. We have just derived the primary Pythagorean identity. There are two more formulas that we can derive from this. By dividing each side of the equation by sine squared theta, we get the following. 1 plus cotangent squared theta equals cosecant. We can also each side by cosine squared theta, and we get this. Tangent squared theta plus 1 equals secant squared theta. These are the three trigonometric Pythagorean identities. Now let us go over some trigonometric properties. First, we will discuss the cofunction identities. What are those? Let us have a right triangle with an angle theta, as shown. Due to the triangle sum theorem, where all angles of a triangle add up to 180 degrees, the complementary angle, or this angle here, will equal 90 minus theta. In radian form, this will be pi by 2 minus theta. Now let us find the trig ratios for this angle. The sine of the angle 90 minus theta is opposite of that angle over the hypotenuse. The opposite of that 90 minus theta angle is actually the adjacent side of the angle theta. We must write this in terms of theta to make things clearer. Therefore, if you remember from before, this is the cosine of the angle theta. Let us do the same for cosine. The cosine of the angle 90 minus theta is adjacent of that angle over the hypotenuse. The adjacent of that 90 minus theta angle is actually the opposite side of the angle theta. This is the sine of theta. Therefore, we have our formulas for sine and cosine of 90 minus theta. We can do the same for tangent. Because it is sine over cosine, we can write this expression. Using the given information we have derived, we can get that tangent of 90 minus theta is cotangent theta. These are our three cofunction trigonometric formulas for pi by 2. Now, let us continue with the symmetry identities. These describe the symmetry of the graphs of the trigonometric functions. Let us have a unit circle centered at the origin, and a point P on the circle with coordinates x, y. Let this be the terminal point for an angle theta. By definition, the coordinates of this point will be x equals cosine theta and y equals sine theta. Now, let's reflect this point across the x-axis, creating a new point P' with coordinates x' and y'. By definition, These coordinates must be x equals cosine theta and y equals negative sine theta, since it is below the x-axis. Notice how the x-coordinate stays the same, while the y-coordinate changes sign from positive to negative. Now, because it is reflected across the x-axis, it will have a terminal angle of negative theta. Therefore, the cosine of this new angle is the x-coordinate, and the sine of this new angle is the y-coordinate. Now let's do tangent of the original angle. Since it is sine over cosine, it stays positive. However, it will become negative for the new angle, meaning that it changes sign. Therefore, here are the three formulas for the symmetry of angles. This was the first video in the Trigonometric Identities series. Watch the next video, part 2, where we will go over the proof of trigonometric addition formulas.